So in this video, we are going to discuss about one of the questions of the JEE Advanced that came in 2023, and it is coming from the chemical equilibrium part. So let's see this question. So in this question, we can say that we have 1 liter of a flask where we have 6 mole of A is present out there, which is undergoing this particular reaction. So as far as the reaction is concerned, the reaction is this one where A is going into P itself. Now the progress of the product formation of this reaction has been given at two temperatures, at temperature T1 and at temperature T2. So we can see that at temperature T1, the concentration of the product, how it is varying with respect to time, it is given, and we can say that after certain amount of time the concentration of P become constant both at the temperature T1 and T2 respectively. And we know that when the concentration become constant, that means the equilibrium has been achieved. That means indirectly from the graph, the concentration of the P at the equilibrium has been given itself at the temperature T1 and at the temperature T2. So we can say that at T1, at temperature T1, the concentration of the product P at equilibrium will be equal to 4 mole per liter itself. And as far as at temperature T2 is concerned, then the product of P, the concentration of the P at equilibrium will be equal to 2 moles per liter. So we can draw the ice table at temperature T1 and T2 respectively. So at T1 we can say that initial the 6 moles of A is present out there and 0 moles of P is there, and now at equilibrium there are at T1 4 moles of P is present out there. That means we can say that 4 moles of P has been produced. That means 4 moles of A has been decomposed, and at equilibrium the number of moles of A is given as 6 minus 4, that will be equal to 2. So 2 moles of A is present out there at equilibrium and 4 moles of P is present out there at equilibrium at the temperature T2. Similarly, at temperature T2 also we can determine the concentration of A and P at the equilibrium. So at temperature T2 we have initial condition 6 mole of A and 0 moles of P, and as far as the equilibrium is concerned, at the equilibrium we have 2 moles of P is there. That means 2 moles of P will be going to be produced. C means consumed, I means initial, E means equilibrium. So if 2 moles of P has been produced, that means 2 moles of A will going to decompose. So at equilibrium we can say that we have 4 moles of A will be there. Now what is the concentration of A and P at the equilibrium? We have determined it. Okay. Now we have to find the value of delta G2 and delta G1. Okay. The standard with Gibbs free energy change, and we know that at equilibrium, that delta G naught is equal to RT ln K minus RT ln K. So I am saying delta G naught 1, that is at minus RT ln K itself. And since we are dealing with the gaseous things, so we have to take K as Kp itself. And here delta G is equal to delta G2 naught. That means this is the standard Gibbs free energy change at the temperature T2. That is R T2 ln Kp itself. And since the temperature is varying, that means the equilibrium constant will also going to be vary itself. Now as far as delta G1 is concerned, what we can write, delta G1 naught will be equal to minus RT1, and then we have ln Kp. Kp value if you find at the temperature T2, that is at the temperature T1, that is the pressure of P by pressure of A itself, and pressure of P will be equal to what? Pressure of P at the equilibrium will be equal to, we know that from the ideal gas condition, pressure will be equal to nRT by V. So N is 4, R is constant, T is the temperature T1, and V is 1 liter itself. And similarly we can write for A also. We have 2 RT1 divided by 1. So this value will be equal to minus RT1 then ln 2. So this is delta G1 naught. Similarly we can find delta G2 naught also. So delta G2 naught will be equal to minus RT2 ln. Kp dash will be equal to how much? We can say if the partial pressure of P at equilibrium and the partial pressure of A at equilibrium at temperature T2. So minus R T2 ln. Partial pressure of P will be equal to what? That will be equal to N, number of moles of P at equilibrium, then R, and then T. T is T2, then volume. Volume is 1 liter. Partial pressure of A, that is N R T divided by volume. So all this will get cancelled. We are going to get the value of minus RT2, then ln 2 by 4, that is 1 by 2 you can say. Now the thing that we need to determine is delta G. You can see that what we have to define, we have to find the difference between delta G2 naught and delta G1 naught. So just subtract these two. Suppose this is equation 1 and this is equation 2. If you subtract both of them, then you'll get the required thing. So delta G2 naught is equal to RT2 ln 1 by 2 minus RT1, that is ln 2 itself. And these things we can write as RT2 ln 2. This is also RT1 ln 2. And now one condition is given. The condition which is provided here is T1 is equal to 2T2. So instead of T1 we can write 2T2. Instead of T1 we can write 2T2. So value that we are going to get is 3 RT2 ln 2. From there we can get RT2 ln 2 to the power 3, and that will be RT2 ln 8, and this value is given. So delta G2 naught minus delta G1 naught is equal to RT2 ln 8, and the same value is given here also, RT2 ln x. So this x, same value is given, RT2 ln x is given. So this x value will be equal to 8 here. So that's it. This is the question, and the crucial equation that we're using here is delta G naught is equal to minus RT ln K. For the gaseous thing, we are taking K as Kp. Thank you.